Hi everyone. Our group has 6 members: Yuhan, Dayi, Mingxia, Chuanyue, Luoyi, and my name is Li Yang. I will introduce credit risk analytics with Spark. As usual, the first step is to process original data, which include delete all rows with missing data, choose rows that the field number of employees is no more than 10 as requested in the problem, save the selected data into a new CSV file for further use, then use tray and test split function to split data into different parts. I draw histograms of all variables to have a basic view about the dataset. As you can see, the first chart is the histogram of target variables delinquency, which 1 means bad credit and 0 means good credit. The majority of samples have good credit. The chart in the second row shows a similar pattern. Most of samples are located in the first interval section, which means there are very few samples have very large values. These values can be outliers in the dataset. Then I conducted gradient boosting, SVM, logistic regression, KNN in Python. Here shows the result I got. As we can see, the performance of these 4 models are very similar. They all have good results with a very low MSE and relatively high accuracy rate. And I do encounter hard time when I run SVM model. It took much longer time than other models. The reason is that the training data is very large. SVM cannot work very well because it requires a lot of computing power to compute the kernel metrics. I also did a cross-validation for KNN and SVM model. Here shows the result of KNN model. The performance for 4 different distance algorithms of different numbers of neighbors. As we can see, the Manhattan algorithm has the best performance when the number of neighbors are less than 20. Overall, the difference of performance is quite modest between these 4 algorithms. Here is the classification reports for these 4 models. Gradient boosting and logistic regression have better performance than other 2 models. The precision and recall for 0 is very high, while that of 1 are very low, which indicates that the models did very well predicting class 0, but did poorly in predicting 1. The second part is to build models in Spark. Before we can use the data to fit the model, we need to pre-process the dataset. Firstly off, transforming data to labeled points so it can be used to fit the models. We also need to remove the header before we use the data, and then split data to training and test data. The result of SVM, logistic regression, and gradient boosting while Spark showed as follows. I used binary classification metrics to calculate area under PR and area under ROC. I also computed the MSE and accuracy rate for these 3 models. As can be seen, gradient boosting has the best performance, and predictions for 1 is not very good. So the area under ROC for for logistic regression and SVM is not very high. The last part, I want to illustrate some problems we encountered and how we solved them. When using logistic regression and SVM in Spark, the predict function cannot work very well for test datasets. So instead of making predictions for the whole dataset, we use for loop to make predictions for each sample in test dataset, and then zip the predictions with test data labels and convert it to RDD. And the next part is Dayi will introduce the question 1.
Question 1 is using Spark to analyze IT and finance stocks. First of all, we retrieve the stock data of 5 IT companies and 5 finance companies from Google from January 1st, 2007 to January 23rd, 2017. The data was saved as a CSV file for further analysis. In the code, we repeatedly replace the Google with Yahoo, Apple, and so on. Here shows the code of computing volatility, plotting data, and visualizing data. We calculated the sequence U, which is the log of the ratio of the two neighbors' closed prices, namely the log return of stock. Then we compute the standard deviation of the U sequence using a method in pandas. Then we compute the volatility, and then we plot the volatility by using matplotlib. Here shows the result of IT companies' stock close price and the volatility. They are Yahoo, Microsoft, Google, Amazon, and Apple. We can see that except Apple, the other 4 companies' stock prices become less risky since 2013. Apple's stock become a less risk security since 2015. Then we did the same computation with other 5 financial companies. They are Citibank, Bank of America, Goldman Sachs, HSBC, and JP Morgan. We found that Citi's stock prices keep a steady low risk, while other companies' stock become less risky since 2014. Here is the summary of visualization of 10 companies' stock price of 10 years. Amazon and Google stock prices are extremely high among 10 companies, meaning that you will be super rich if you buy any of these 2 stocks 10 years ago. Amazing result. Secondly, we use the built-in function to compute the mean, median, standard deviation, skewness, and kurtosis. Here is the table summarizing the statistical analysis of close price of IT companies. And here is the table summarizing the statistical analysis of close prices of financial companies. Then we change the object from close price to volume. The same manipulation applied to it. Here shows the analysis of volume of IT companies and the volume of financial companies. All of the statistical analysis is valuable reference to investors and the stock traders. And here comes the question 2, which will be presented by Yuhan.